I think we should be right to go. Hopefully that's got sound recording in it. I believe it's on. Yep. Okay, so what we're going to look at now is the hierarchy of nomenclature. And the hierarchy is just telling us which ones are the ranking of most important to least important. As far as the name, functional groups. And normally, well, we can use a thought process about oxidation to lead to these ideas. So the most important ones are carboxylic acids, and that means that if you've got a carboxylic acid functional group present, that's going to mean that you've got acid at the end of its name. Acid anhydrides are next, which aren't important for us, and then esters are next. Acyl halides, we don't worry about that. Amides, nitriles, aldehydes, ketones, alcohols, thiols, amines, ethers, sulfides, alkanes. Well, actually alkenes are next, and then alkanes. Okay, so that's the most important down to the least important. And you're probably already aware of some of this because I've skipped alkyl halides. I should put that in there. Alkane. Those of you who are doing biology have probably heard of amino acids. And so that's telling you that it's the same thing, isn't it? That the way we're naming it is that the acid part is the important part that goes at the end of its name. It has an amino group as well. And that's I guess the more commonly used biological terms that are in a reasonably common everyday life. These sorts of things. So you don't need to worry about necessarily about them, except just to have a bit of an idea that if we have the amine, because it's lower down in the importance, and we have an acid group, then the amino part goes on the front. The same with an alkyl halide. We know that if we had a bromo or iodo or chloro attached to a ketone, for example, then we're going to just put the bromo, chloro, iodo out the front, and then we're going to name it with the -one at the end for the ketone. So that's just a general mud map, if you like, of it. And you put the more important functional group last. Okay.
And for each of these, if there's more than one, you use
the di. That's right. Yep. Yeah. So the di-tri. So, and with alcohols, we see a lot of diols, and we also see dicarboxylic acids. When we're making polyesters. Yeah. So we'll come to that later on. That we actually, because we know, well, you will know soon, that we make esters by reacting alcohols with carboxylic acids. And so a polyester is lots of esters joined together in a long chain. And so that's where we need to have multiple functional groups to join together in a long chain. Alrighty, so that, like I said, it's not a really big thing, but it probably doesn't hurt for you to have a bit of an idea of what order they're in. Any other comments?